match is going to do exactly what it sounds like it will do. It is going to allow us to compare a value against a series of patterns and then execute code based on the matching pattern. So we did it earlier in one of our examples when we were setting up a pet enum, and what we did was basically said, hey, match on yourself, and if you're a dog, I want you to print out I am a dog. So in essence, that's what the match statement does. So let's create another example, and we'll create a new function called fn plus 1. And we're going to take in an option I32, and we want to return an option of type I32. And then in here, we're going to say we want to match on X. If none is passed in, then that's what we want to return, none. But if something is passed in, then we want to return sum of I plus 1. So when we run this, or call this I should say, we'll say let 5 equals sum I, right? So this is essentially what's going to get converted to sum 5 right there, that's sum of I. And then we say let 6 equals plus 1 of 5. And then we'll say let none equals plus 1 of none. And then let's print it out. So we'll print it out. And we'll have 6 in here. And it's probably going to want it to be just like that. Okay? Go back to the terminal. Cargo, run it. And that's exactly what we got returned, was sum 6. So now if we come back in here and we do none, we would expect none to be returned. And that's exactly what happened. So what this function did was it accepted a parameter of x, which we passed in here was 5, and then inside of the 5 variable contained sum 5. And we matched on sum of I, so any value could have been passed in here, and then whatever the value that sum contained, we added 1 to it. So what happens if we forget to add in the num statement? We already see we get an error coming. So it says we got an error. Okay, pattern none not covered. So the compiler will catch it for us. Matches in Rust are exhaustive, meaning that every possibility must be exhausted for the code to be valid. So we need to make sure that we cover every case, because otherwise it will likely introduce a bug into our code. So we can use catch-all patterns to be able to handle all other situations. So let me come back in here and we'll just re-put in none. And then let's go back and look at our pet enum and show that for all other pets, we will print out something different. So we want to come up here and actually we'll come down here and we'll create a function that says what pet. And then in here we'll take our input, which is going to be a reference to a string slice, and then we don't need to return anything in this case, but we're going to match on input. So what we'll do in here is we'll say, hey, we have dog, and we're going to return I have a dog. And then for all of our other cases, we'll have our fish. We'll have our cat. And then we can see that our input is already kind of like hinting to us, hey, something needs to be covered. So if we hover over it, it'll tell us the non-exhaustive pattern is not covered. And it's telling us to use an underscore. So if we put in an underscore here and then just say, hey, I have no clue what pet you have. Well, now it seems to work because we're using this underscore to cover all other situations. So now let's test this out real quick. We'll say what pet, and we'll say dog. What pet? Cat. What pet? And cow. So now if we run this, we expect to see I have a dog, I have a cat, and I have no clue what pet you have. And that's exactly what we got. So it's important to remember that match is exhaustive. So we have to try to cover every single case that we could have. And then we can use this little underscore right here to basically say, hey, if it doesn't match anything else, then by default, run this.